Hi, this is a video about Haskell exceptions, about how they are thrown, and about how they interact with lazy evaluation. So I have this example program here. I have this inner do block that simply returns a pure value, and the outer do block takes the value and prints it. Suppose that I were worried about possible exceptions thrown here. So uh, I'm going to import control exception, and I'm going to install a non-exception handler here that simply prints a message. Okay, but of course nothing will happen because we are not really throwing exceptions here, so the message won't be shown. But let's go and actually throw an exception. And to throw exception in IO blocks, I'm going to use the throwIO function, which you pass it an exception value and returns an IO action. And when the IO action is executed, the exception is raised. So I'm going to use throwIO, and I'm going to create like an IO exception here. By the way, I'm using block arguments, so I'm going to use do's instead of dollar, like perhaps a bad habit I have. So this is an IO exception, and when this statement is executed, the IO exception will be thrown. So this is very much like how exception throwing statements work in other languages. So no surprises here. Okay, exception detected. But Haskell also has another way of throwing exceptions. Instead of using throwIO, you can use throw. And if you look at the signatures, throw can hide the exception in any Haskell value. Okay, so it doesn't force you to work in the IO monad. So what we could do is, okay, I'm going to comment this. Pure throw okay, like I'm going to use those. So if we look here, throw has type int. So now this IO statement, when executed, it returns a value that hides an exception. But the statement doesn't throw an exception by itself. And what is the difference? So how will this behave with respect to an exception? So look, now the exception is not detecting this exception here. Why? Because we are not evaluating inside this do block. We are not evaluating this int, the int that hides the exception, and so it exits it without triggering it, and it's only triggered raised when we try to evaluate the value in order to print it. So these kinds of exceptions hidden inside pure values sometimes they are called imprecise exceptions. For example, an undefined will behave similarly here, or also error. Okay. So suppose we did want the on exception to be aware of this error hidden inside the int. How could we do that? So there is a function in control exception called evaluate. And what it does is you pass it a value and it returns an IO action, and it ensures you, it guarantees you that when the IO action is executed, the parameter will be evaluated to weak head normal form. That is up to the outermost constructor. So I'm going to use evaluate instead of pure here, and while what will happen here? Okay, so now the exception detects the exception. So because we evaluate, we execute this IO action, and evaluate ensures that the execution also triggers evaluation of this value of type int, and the exception is raised within the scope of an exception. So, by the way, you may ask yourself, when should I use throw and when should I use throwIO? The answer is that you should use throwIO whenever possible, uh, because it's way more predictable, as we have seen. But sometimes you can do that. For example, imagine that you are inside a pure arithmetical computation and you encounter a division by zero. So this division by zero error will be hidden inside the int value, uh, like with throw, like it won't be detected by the exception. Okay. Let's add a little twist. Imagine that instead of returning from the inner do block and single int, we return a list of ints. And we return a list of ints that contains as elements like a lot of imprecise exceptions, like the throw, the undefined, and let's put an error here. So what will happen now? Will it print exception detected or not? Remember that we are using the evaluate. It doesn't. And why? Well, remember that the evaluate only ensures that the, the argument is evaluated to weak head normal form. And what is weak head normal form in this list? It's really this constructor. So evaluate only ensures that we can evaluate up to the cons constructor, but it doesn't really evaluate the elements. Okay. So what can we do now? What if we wanted to actually detect the errors inside the list in the scope of these two blocks? What we can do is there is a Haskell library called deepseq, and what it provides is functions and helper type classes to deeply evaluate values. And if we deeply evaluated this list before exiting this do block, so the errors will be raised inside the do block and detected by an exception. And in particular, we are going to use the deepseq function force. And how does it work? Force, you pass it an argument, and it guarantees you that if the resulting value is evaluated to weak head normal form, the argument will be fully evaluated. So we are going to use force here. Of course, I haven't imported. Okay. And let's see if it works. Okay, now the message is being printed. So remember, we are executing this IO action. The evaluate ensures that this entire argument is evaluated to weak head normal form, and the force ensures that this is deeply evaluated. Okay. In fact, in the documentation for force, like it already tells you that combining it with evaluate is a common pattern if you need it. Okay, so a final twist. Do we really need evaluate here? What if we go back to pure? Like we already have the force. Maybe it will work. No, it won't. And can you can you tell why the message is not being printed? Okay, the reason is that even if we have force here, like the pure is returning this entire value unevaluated. It doesn't do anything with it, it simply returns it without evaluating it at all. So it's only evaluated to weak head normal form here, and that's what triggers the deep evaluation. But it's done here. So we do really need the evaluate here. Oh, okay. So as we have seen, maintaining full strictness in Haskell sometimes is a bit involved because you really do need to maintain it at every step. And sometimes it's easy to forget to force strictness at one point and you get unexpected results. So this is all. Bye.